Naka-beautify. Na-on man to, no? Okay, kamo po, di ba? Okay na ta. Hamis kayo ninyo mga nawang sa profile pic ninyo. Okay. So, anyway, we have here an inclined plane, the angled A, and the mass M, and then at height H. So, let's neglect friction. No friction. So, the given here is M, H, and the angle A. We want to know is the initial velocity is V naught is 0. We want to know what is the velocity as it reaches the bottom. Okay? And how do we do this? Okay, in our previous unsay buhaton nato diri, we construct an axis, free body diagram, and then identify the forces. This is weight. You have the normal force and no friction. So, from this, we show that summation of force along x, this is the x-axis, hindi na ako ni-explain because we already talked about this, equals, on the positive side is weight x. What is weight x? That's mg sine theta. Tama? So, this is mg sine theta plus any other. Wala. So, wala na. So, this is equal to ma. It cannot be 0, no? Because walay mo pugong ana. Okay. So, this is MA. So, that our acceleration is equal to G sine of, this is A. No? G sine of A. Okay? So, this is what we obtained last time. And what is now the velocity at this, when it reaches this one, at this point? Well, we can use, what is our given? You have 8. We need this one. But this right here, we can call this X. Kani, up to the bottom. Let's call that X. And so we have, can we get X? Yes. Because we have H and A. So we have X, we have A already, and we have V naught to be equal to 0. This is our given. So what equation will we use? It's easy. We just need to use katong 2AX equals V squared minus V naught squared. In this case, what is our A? That is 2G. Sine theta times x is just, based on the geometry, that is just h over, okay, ganong a, sige mo theta, sine A equals v squared because we set this to be 0. So, v is equal to square root of 2gh. Gano'n, na-op? Okay. Okay na, pwede na mo. Pero okay na, yan, narapod ni mo na siya. Okay, square root of 2gh. And I think we obtained this last time. Now, I'll modify the problem. I'll make the angle B. Instead of A, I'll use B. What do I get? Obviously, there's no angle here. So, whatever B is, B could be kani, that could be B, or that could be B, kaning dire, a very low inclined plane with a low angle, you get the same because this is independent of the angle, di ba? This is just sine B and then over sine B. It will cancel out. So, we obtain the same velocity. It doesn't matter. But, here's the thing. I have another inclined plane. Dire gyapon nagsugod, and then I'll break it into two. This is H1, and this is H2. Such that H1 plus H2 equals H. I want to know, and let this to be angle A, and let this to be angle B. What is now the velocity at the bottom? Same condition, V naught equals 0. Same mass, no friction. Okay? So, what we will do is we will divide it into two, di ba? This one has the same solution, right? Exactly, kani dire. You have the mass, so meaning that this from this segment A, let's call this region A, what is the solution? Just exactly kani, no? Because it's just, pareho lang. So that, clearly, the velocity on A, at the moment it reaches here, is, what is that? We can call this VA square root of 2G H1. Right? Now, we now go into this one. Dire. Oh, this is now a different system. But what is our acceleration for B? Let's call this region A and region B. What is our acceleration? Well, we still have the same acceleration. If you draw a free body diagram, dire, paana siya, still, the weight is mg sine B. Sa ato pa, that means here that A, on this region right here. What is A here? A is G sine A. Means here, A is equal to G sine B. Right? So, unsay given ani, we have V naught, which is the initial velocity here, which is just that. And then, we want to find V. What we are given is, can we find this? Yes. We can call this as our X. So, X is again, H2 over sine B. Okay? So, unsay atong buhaton ani? H2 is, okay. What is now the velocity at that point? So again, 2ax, same equation. So 2g sine b equals, x is H2 over sine b equals v squared, which is, mo na ang unknown. V squared minus v naught squared. What is v naught? This is the initial velocity here. Okay, ano lang nato sa part, no? So, that would be 2gh1. Cancel. What our v squared is 2gh2 plus 2gh1. And we have v is equal to 2gh1 plus h2. And together, our v is square root of 2gh. So, na ano ninyo ang kuanane? Ang sa the example? It's 2gh. The same as this one. Okay? Okay, now let's try one more thing. Let's divide this into 3 regions. A, B, and C. Okay. This is angle A, angle B, and angle C. When we know what is A, acceleration at A, that is G sine A. What is the velocity as it reaches this point? That's VA, we can call that VA equals square root of 2GH1. Tama? Now, unsay velocity dire? Well, the same as this. But not this one. 2G. That means BB would be equal to 2G H1 plus H2. This is my H1. That would be my H2. And this would be my H3. Such that H1 plus H2 plus H3 is H. Okay. Nakuha ninyo? So, square root. So, sa'yo nahitabo karon. Diri na lang ta karon. And following this, V squared at C, at point C, is equal to, according to this, if you plug in, also may AC. What is AC? AC is G sine C, right? So again, we have 2A, which is G sine C, times this H3. This one, X3. We can call that X3. So that is H3 over sine C equals V squared. Okay, asa na ta? Okay, here, what is V naught squared? This will be our initial velocity. So that would be 2G H1 plus H2. And this is 2G H3. Move that one here. So plus 2G H1 plus H2 equals V squared. What do we get? V squared is equal to 2G H1 plus H2 plus H3. And we have V is equal to 2GH square root. We obtain the same. And even if we break that one into 4 kabuok, okay, the same. But ang question karon, why is this? That's what we are going to investigate. And also, yes, we have solved this. But this is a very tedious calculation. And actually, we already made the shortcut. We already did some shortcut. That's why the solution becomes simplified because we did some shortcuts. But technically, kung magkadaghan na siya, anak nimo na siya, that will be the number of times you're going to repeat this. And you will expect that at the end, as long as there is no friction, you will get square root of the initial, as long as all of them starts at 0 from the top. Regardless. And even if projectile motion, free fall, you calculate free fall. Let's try free fall. What's free fall? Since we'll use 2G, y minus y naught, right? Equals, this is v naught squared minus v squared, tama? In the free fall. What is y? We set y now is evaluate at 0, so this is now 2G. What is y naught? This is h, so this is negative. Equals, what is v naught? Since ano lang siya, this will be 0, and you have minus v squared, and you get still, v is equal to 2 square root of 2gh. Right? And this is a decisive, this is something, we are observing something. But the configuration is actually making the, kumbaga pa, the solution complicated. It depends on the configuration. And why is that? Because of the nature of Newton's laws. It's written in vector form. So in Newton's laws, we use Newton's laws to identify the forces, and then solve for the acceleration. Once we know the acceleration, we get into kinematics. Which kinematics? Constant, uniformly accelerated motion, as long as the force is constant. Okay? But now, we move to a non-constant force. Non-constant forces. When we say of non-constant forces, everything that we have discussed so far are constant forces. Tension. As you move the block, the tension doesn't change. As long as you pull it constantly. Stupid nga, ano ba? Of course, it doesn't change because you pull it constantly. But, well, yeah, constant siya. Also, friction is a constant force. And gravitational force is a constant force. But actually, it's not. Weight or the gravitational force, Fg, equals mg. It's negative mg, no? This is not actually correct. Not entirely correct. The gravitational force is not a constant force. This is the gravitational force at the surface of the Earth. In fact, as long as you are near enough the surface of the Earth, your weight, the gravitational force, because we call it weight, the gravitational force, the effect of gravity on us. But what if you are flying at maybe 10 kilometers above sea level altitude? Do we still have the same weight? And the answer is no and yes. So, manang no and yes, sir. Well, no, we don't have exactly the same weight. But yes, we have the same weight for as long as we round up to a certain decimal points. Meaning that the difference is small. But there is that difference. But what if you get now to 1,000 kilometers above sea level? Like kung asa ang mga orbits, space station. Now, it's no longer the same. Why? Because the gravitational force, we will not be discussing, but I'm just giving you this, this will be important later because the gravitational force will arise because of a certain important function. Okay, this is mg, the true gravitational force is g m1 m2 over r squared. How they are separated? Now, between me and the Earth, the first mass is me, and m2 is the Earth. And r2 is my distance from the center of the Earth, as if all of the Earth is concentrated at the center, at the core. Okay? So, mauni ka ng iyahang form. Now, notice that r, that r is actually just the radius of the Earth. Because I'm at the surface of the Earth. The radius of the Earth is on the order of what? About 7,000, something 6,000 plus kilometers. Now, that is square, 16,000 kilometers square. Compare a difference of 15 kilometers. Will it matter? No, it won't. Okay? So, 15 kilometers difference. Mura kumbaga pa, this is the whole radius, and then when I climb to 15 kilometers, naalang gyapon dira, but very small change. And so that is negligible. So as of now, if we don't go into gravitation, in dynamics we treat weight as constant. Okay, it's a constant force. Okay, but I caution ni siya because nganong gi-emphasize nako siya nga dili constant force. And while I say that it's constant now because later nganong kinahanglan nato na siya, no? Because of the certain definition. Okay. What are example of non-constant forces? F as a function of time and F as a function of position and F as a function of velocity. These are non-constant forces. But it doesn't mean that you can have, for the same system, you can, lahi ni siya. No. For the same system, if you have a non-constant force, you can express it in this, or this, or this. And it will mean the same force for the same system. Okay? Pwede siya ani. How is that? Well, for example, composition of function na siya. You have g of u to be, let's say, 1 over u squared minus 1. That's g of u. And I will have u of s as, let's say, s squared plus 1. Can I have g of s? Yes. G of s is just 1 over s squared plus 1 squared minus 1. And of course, simplify that one. That is g of s. Now, of course, with g, I can get prime dg over du. Tama? Ang question is, can I also find dg over ds? Because I can express g as a function of s. This will be important. Dili. Pwede. What is that rule? The chain rule. So we will be using the chain rule now. We'll start with this. And by f of x, I mean f of x equals m. F of x is a function and then this is dv over dt. But this equation is actually some sort of absurd. Or something that is not compatible. Nganong dili man siya compatible? Why? Why is it not compatible? Dili siya appropriate siguro. Not compatible, but it's not appropriate. Because here is a function of x, while this one is a function of t. Of course, v is a function of t, right? V is a function of t. But this one here is a function of x. So what I'm gonna do is that I will force this to become a function of t. Nga naman, because I need, this is taking v as v of t. But, ano ni siya? Point 1, initial point, and final point. Velocity V naught, velocity V. This one right here is at sometime, let's say, you can take this as t equals 0, and sometime t equals this. Diba? So, nag-change siya, right? The velocity changes. That's why you have V of t. But then, is this the same x position? No. That means that when we say V is a function of time, and since in order to move from one position to the next, you need time, that means that also velocity must depend on position, right? So we can find an equivalent function V of x, which is V as a function of x. And why is that? Well, it's easy to go from this one to this one. Composition of function. Kabalota, nga naman. Why? Because x is clearly a function of t. This is a parameterization, right? And this was our lesson. What we obtain from Newton's equations are parameterized equation. So clearly, x is a function of time. So we have here, v of x is just equal to v of x of t. Ano? And this is clearly v of t. Tama? Just like katong ganiha dito, g of u and then u of s. You can find g of s. Okay. So, that means we force this one, but then, usa tong ganiha, you have g of u and then u of s. And then we can have g of s. How do we find dg over ds? It is chain rule, right? This is dg over du times du over ds. So we will do that one here. So this is equal to m dv over dx and then dx over dt. Right? But this one, and tanawa, this one right here, what's dx over dt? That's just v. No, this is just v. That means we have now our equation is f of x. We move dx on this side right here. So f of x dx equals mv dv. So we have this. And this is now integrable. Well, as we assume that f is integrable, clearly the right-hand side is integrable. Ngano integrable man eh? We are sure of this. Why? Because this is an integration with respect to v. dv. So clearly, you can integrate this. This, we don't know yet. It depends on the function f of x. Now, unsa ning f of x? The force is dependent on the position. An example of that is, just for example, the wind. The wind here, the direction and magnitude of the wind here is different from dito. Okay? So, clearly, at every point, you define now the force changes. So, for example, and I think, yeah, let's say this is already possible that the force is going this way. At this point, the force is going that way. At this point, the force is going that way. At every point, you have a different value of f. So we have f, which is a vector, is a function of what is this? A function of the position. What is our position vector? That is r. This is what we call a vector field. Okay? And I think nagsugod na ako nung na-introduce, di ba? Sa kuan? Yeah, vector field. So, I already introduced this one, this concept. This f of r. So, I'm going to generalize this into 3D. Okay? But we have to be you have to, kailangan niyo, okay, medyo musalom ta karon. Okay? So, muna actually nagdala ko ana. So, in 3D, we have f as a function of r equals m dv over dt. Okay. Now, what can I do with vectors? Akong buhaton diri is that I'll dot both sides with dot dr. It's a dot product. Okay? So, on this side, you have f dot dr. I will no longer write f of r. It's understood f is a function of r. And on the right-hand side, you have dm, dv, and then I'll transfer dt dire. I will have dr over dt. What is dr over dt? That's v. Okay? So this is dv dot v. So meaning I can write this as mv dot dv. Okay. mv dot dv. Okay. Now let's understand this. Ako sa ning erase ha. It's just the same, only katong diri og kani is the same, but this is one dimension, this is general 3 dimensions. Suppose you have this curve, and a curve can be parameterized by a position vector, right? R of t. And we already did this one. So that's why giuna mo nang conventionally university physics do not discuss parameterization. Okay? If you go into Young and Friedman's book, I think there's no discussion on parameterization there in almost every other university physics books. But we started with parameterization because I want you to understand the very nature of the mathematics nga ato ang gikuanan diri. Okay? And it's not difficult. Okay, suppose that here, okay, let's take this as our, this is r of t naught, di ba? Or we can call this as r naught. And at some point, nasa dire. This one right here is r of t, or just r at any t. This is a curve parameterized in terms of time. So what is r right here? R of t is equal to x of t I plus y of t j plus z of t k. Okay? Or to write it simply, r is equal to xi plus yj plus zk. Or in point form, katong x, y, and z. Where x, y, and z are functions of time. Now, that means, kung tanaw nato, we are integrating. In order to solve this, we have to integrate, right? We're integrating in r. So meaning we are integrating through this curve. Because this is our r. This is not any r, this is a parameterized r, a curve that we have chosen. We can actually choose any other curve, but let's assume that this is the r that we have chosen. So this is now, we start with what? R naught. So meaning, starting from R naught to R. Or this is equivalent saying that we start with X naught, Y naught, and Z naught. This is the initial point, kani. Naka ninyo? By the way, medyo posibleng masubra tagamay dire. We have to finish this lecture. Nakuha? Okay. So we have to kuan, extend some, pero I think kaya ra ni siya gano. Okay, to some what? To the point X, Y, and Z. Right? How about this one? When the particle is at R naught, what is the velocity? What is the velocity when the particle is at R naught? Saman? That is, well, of course, this is V naught. Now, tanaw natin sa geometry. Asa directed ang V naught? Can we know the vector V naught from this drawing? Ngunit kinahanglan na ninyo sa concept. Kasi itong gikuano? Yes, we can. Actually, V naught, what is the velocity vector? Is tangent to the curve at any time. So, this must be the direction of V naught. Right? Tangent to that curve. And this one right here is the direction of our V. At any point, V is directed tangent, di ba? I think first meeting or second meeting. So, this is to V. When it is at R, its velocity is V. So, muna ibot pasabot ana, no? But by the way, what is our V? V is just Vxi plus Vyj plus Vzk. Okay. So, karon, let's understand this one. V dot dv. We have a vector dv. Now, dv has the same direction as the acceleration. Why? Why is that? dv has the same direction with the acceleration. Why? Because the acceleration is dv over dt. So what are you multiplying with dv? It's 1 over dt. That's a scalar, di ba? Scalar, and that's positive, doesn't change the direction. Meaning, the direction of dv is where the direction of acceleration. So this is actually, well, kung tanawin, if the curve is going right here, the acceleration is most likely naa dire. So dv is on this one. The acceleration cannot be on the side. Kaya nga naman, because it's actually turned into the side, right? So it changes in direction. So the acceleration is going there. So here we are projecting the velocity with acceleration because this is that product. What do you mean by that product? Kasi geometric importance niya, it's actually a projection. And why is that a projection? Let's tanawa. Let this to be I hat and this is J hat. And I have a vector A. Tama? Now, kani, what is this? Let this angle theta. This is AX, right? Tama? What is AX? This is the shadow of A viewed in the I direction. Ug naa kay sun dito as ang shadow, mo ni siya. The projection of A onto that plane, that axis. And why is this a projection? And I will show to you that this is the dot product is actually a projection. Well, a projection times a certain number. But it's more, pinaka-ano niya sa projection. So, how do you get, what's the magnitude of this? A, right? How do you get this AX? AX is A cosine theta. Right? Now, how do you define A dot I? This is the magnitude of A times the magnitude of I times cosine of the angle between them. What is the magnitude of I? It's 1. So this is A cosine theta. That's why it's a projection. Okay? Or kung tanawin mo, what is A dot I? You can do it. What is A? A is given by AXI plus AYJ plus AZK. So A dot I, unsay pwede nimo, kani ang I madat nimo sa J dili, right? It becomes 0. I dot J, I dot K is 0. So what you only have is AXI dot I. Tama? And this is I dot I is 1, so this is again AX. So what the wisdom of that product is actually you're projecting something onto a certain vector onto the direction of another vector. For example, if you have A and you have B, what is A dot B? A dot B is actually projecting B as if that the sun is directly perpendicular to B. You get this as A cosine of theta, this one. And of course, times B. Mo nang dili siya projection sana, nasa product, nasa certain nga nabilin. Pero what we are interested actually with that product is, well, many times we are interested in both, but pero ang pinaka-ano nato karon is that we want this. So the dot product is a way of projecting a vector onto another vector by this one, geometrically. So, nganong gi-ano ko na siya? Why do I include this one? Because we are taking the dot product of V and the acceleration. Right? Projecting V onto the direction of the acceleration. And why is that? Well, it will become clear on this side right here. Pero ako na lang saning, what I will do is evaluate this integral. What is V dot dV? How do you integrate a vector with respect to a vector differential? Well, what is Again, V is Vxi plus Vyj plus Vzk. And then dV now becomes dVxi plus dVyj plus dVzk. So V.dv is, di ba kanila ang magpares? No? Kanilang. So V.dv, this is now M, pwede na ako siya igawas, the integral of, kana siya, this is Vx dVx plus Vy dVy plus Vz dVz. Okay? Sabtan? Tama? Now, this is integrated to what? V naught x, V naught y, V naught z to Vx, Vy, Vz. Well, you can use some dummy variable din, no? Just to emphasize the integration. This is dummy variable prime. What is the integral of this? So, ang isa ka integral na break siya into tulo ka single integrals. The sum of 3 single integrals. Nakuha ninyo? So, that means, unsa man ni siya karon? What's the integral of Vx dVx? That's 1/2 Vx squared over 2. The same this one. So, tanan sila na ay 1/2, right? So, this is M times 1/2 Vx squared plus 1/2 Vy squared plus 1/2 Vz squared. Iga nga, oy. Oily na niyong nawong sa... Oily ang nawong dia. Dili ra? Okay. Of course, minus unsa? The initial, di ba? We have to swap because integrating ane. So, minus 1/2 Vx, ano ba? V naught x squared minus 1/2 V naught y squared minus 1/2 V naught z squared. And if we simplify this, we take 1/2. So, mahimo ni siyang ana and same rear, no? Ma-plus, plus, tama. What is this? That is the square of V. So, technically, we can actually, tanaw na to, this is now 1/2 M V dot V, right? Because this is V dot V. Minus 1/2 M, unsa ni? V naught dot V naught. Or we actually have, we can just say this is 1/2 M V squared minus 1/2 M V naught squared. Asa? Okay. So, let's call 1/2 MV squared as K minus, sa ato pa, this is K naught. Or we can call this as delta K. We will go back to this one. Okay? So, the right-hand side is just equal to delta K. What is K? Now, if we analyze K, K is it's not velocity dependent, it's speed dependent. Because ang kung sa kalahian sa speed dependent o velocity dependent is a vector. Speed dependent is a scalar. Kung ang velocity dependent, it can be negative. For speed dependent, it can never be negative, or if it's negative, it can never be positive. So, it is speed dependent. The faster, the greater it is, square of that. And also, it's directly related to the mass. So, this is directly related to the movement. The greater the mass, the greater is this quantity, and the greater the speed, also the greater this quantity. No speed to the left or to the right, or no direction preferred. It's only the magnitude of the speed. So, we can call this now an energy. And since this is associated with movement, with velocity, this is actually what we call the kinetic energy. That's why it's called the kinetic energy. So this is the initial kinetic energy minus the final kinetic energy. Now, we have delta K right here. Tanaw nato ni siya dire. We will now evaluate that second one. F.dr. But before that, we need to understand something. We have a vector field F that dr. Kanina siya. At every point here, di ba na F? Kani dire, F is here, F is there. Also, on the points on the F can have a different value, right? Tama? From here, F might be there. Here, F is here. Kani, F could be, whatever is that. Okay? At every point in space, there is an F. Okay. That means, look at this one dire. Tanaw nato ni siya. You have here, paana. Nakakasaaning nga point mo, niya to ang R. So this is our R. And at this point, let's say our F is going that way. Or, ito na lang ikoan be. At this point, your F is going this way. At this point, not R, but this is our R. But what is the direction of our dr? Because f dot dr, it's tangent, right? So, we already explained this to you. This is the direction of dr. That is the direction of dr. So, here, we are projecting f with the possible next yung imong displacement. Tama? Why is that important? Now, notice this one. This is our F and that is our dr. What if our F is going this way? What is F dot dr? This one, is F dot dr positive kani or negative? It's positive, right? Because theta is less than 90. Now, how about this one? The theta is greater than 90. What is f dot dr? It's negative. So, tanawa ni siya. Whenever, if f is some sort, is assisting dr, it adds this. Unsa man ni siya? This is just an addition, tama? Infinite addition. So, murag kumbaga pa, whenever f is on that side nga it's helping us. It's some sort of, we are benefiting something. Nakuha? Maybe that is confidence or maybe whatever is that. There is something being added to us as long as we move nga dire. But what if we are some sort of countering F? Something is being subtracted to us. Nasabtan niyo? So, mo na yung wisdom, ani. And in fact, this is the direction of dr same as V. What is the direction of F? Same as dV. So we are taking actually not same dot product, but same vector direction of vectors. Nakuha niyo? So this f dot dr, and we know unsa man ni siya. This must be a scalar now because this is a dot product of two functions. So we will give it a name, W. That W is it adds something to us whenever some sort of, we are aligned with the force somewhere, the force padulong dito, and then we're heading here, it adds because we have that f dot dr, positive. And then if we add up, it's always, nag-add siya, right? But if, tanaw nimo, if f padulong dito, and dire, it's negative. It's a subtracting from something from us. So it's giving us something. It can add something to us, at the same time, it can remove. Okay, so let's understand that more deeply. That f dot dr. Okay, asan na ta? Okay, so it's the projection of f. How much is being given? Well, the projection, what is being given is some sort of how much is this, right? How much is f? How much is f? Unsa, murag taking the, for example, if we are going this way, murag ani, if we are going that way, and f is right here, we are benefiting more than if f is right here, right? Okay? Because we are taking the component of f. Tama? What is the component of f here? Kana, times that. How about this one? It's small times that. So this is, we are benefiting from that. And the more that f is parallel, the more that we benefit. And if f is on the dire, sa metabo, it takes something. There's a price to pay of countering. So this is some sort of a price to pay of either going with the force or countering the force or the flow. So, mao na siya ibot pasabot. Now, before we do this, okay, we now take F, we break F as FNC plus FC. FNC is the non-conservative force. We need to do this. So sa ato pa, this integral becomes integral, this is W, integral of FNC dot dr plus the integral of FC dot dr. Why do we separate this one? Because of this very important thing. And you will understand that ma-relate na siya dito sa katong problem nato nga nagsugod ta. The light is still enough. Okay ra? Sige. So, asa naman ta? Okay, nagay ta. Okay, kani siya. This is a non-conservative force and a conservative force. Example of non-conservative force, and you will later see, these are actually contact forces, example of that. Contact forces, usually, constraint forces. A conservative force is a position-dependent force. But not all position-dependent force are conservative force. Okay? But a conservative force is position-dependent forces. Kung mauna, gi-explain ako ganiha, that's why I explained to you that gravity is not a position-dependent force in general. Because gravity is actually a conservative force. Conservative forces are position-dependent forces. Why? Because of the definition. For one dimension, F is conservative if you can find a function u, which is a function of the coordinates, let's say x for one dimension, and f now is just the derivative of that, the slope of u with respect to the coordinates. Okay? This is the derivative. Well, napay additional, but we will not go into the additional, that one, katupang partial, blah, blah, blah. I will not go into that. Okay? Kanisha, this is actually the, f is conservative if there is a function, and this function u of x is a scalar function. F is a vector field, therefore this must be a scalar field. Now, you already have visualized vector field. What is a scalar field now? A scalar field is a function that returns a scalar. It's not a vector. Okay? Unsay ang f nato? Ang f has components. What is f? This is fxi plus fyj plus fzk. Right? What is this? Well, it's just u. So, f is conservative if it is a derivative of dx. But this is actually a special case. This is one dimension. We have to go into 3 dimensions. That means that we need something that generalizes the derivative into vectors. I mean, a vector derivative. Can we have a vector derivative? And the answer is yes. Okay? I will construct a vector derivative. And for that, okay, by the way, in order for that, we will assume na at our u is a function of the coordinates x, y, z, or actually u is a function of r. Now, we can differentiate u with respect to x, right? Tama? We can differentiate with respect to x. But whenever this one appears, we know that u, what we will write here is a function of x, f of x. But this is not true. Nga naman, because we know that u is not a function of x. It's a function of 3 coordinates. So, in order to emphasize that it's not only a function of x, we need what we call the partial derivative. And they say that in your calculus, you did not reach the level of multivariable calculus. Wala mo kaabot. So, this is just fancy notation, no? It's the Greek letter delta. the du over dx becomes partial over partial. We call this delta u over delta x, or we read it as partial whenever we speak it, some of it, meaning a partial derivative. How do we take the partial derivative of u? Well, the same as with respect to x, well, the same as taking the total derivative of u with respect to x, only you treat all other variable as constant, meaning ma-zero ang x, y, y and z. They are constant, considered to be constant. And then when you take, sa ato pa, we have three partial derivatives here. Partial u over partial y and partial u over partial z. Nako, dire. Okay. So it's not actually difficult to imagine. I'll erase this one now. Kani siya. I will construct a vector because here, what is our operator here? Our operator is d over dx. Can we have a vector operator? Yes. I will construct now a vector operator. Out of this, I will construct a vector out of this differential operator. I will construct now partial over partial x, I, plus partial over partial y, j, plus partial over partial z, k. And then, since this is a vector differential operator, it can act on both vectors in a scalar. For a scalar function, let's say u, all we have to do is multiply. Scalar multiplication, tama? That is just scalar multiplication. So what is scalar multiplication? You just transfer u dito. Nakuha? U dire, but you can put u dito. So much better if we write this not as this one, but like this. I hat plus j hat partial over partial y plus k hat partial over partial z. And then when we act this with u, what do we get? We now have a vector. I hat partial u over partial x plus j hat partial u over partial y plus k hat partial u over partial z, right? Out of the scalar u, we now have, is this a vector? This is a vector, right? This is the x component. Whatever that one is, if we let this to be, let's say, g, unsa man ni siya? This is gx, right? This one is gy, and this is gz. It's, sayo na, no? Can you follow everything? After the race? No? Okay, logical man tanan. Okay, now I'll call this now vector differential operator as the del. That triangle. It's actually the del operator, del. It's a vector differential operator. And what can del do? Sa ato pa, this one, sa ato pa, g now is equal to del u. Right? Tama? How about, can we do something with del? Yes, we can actually take del dot for any vector a. A. What is a? AXI plus AYJ. Sa ato pa, partial over, kani siya, ang I will only act at this one. Right? So this is partial AX over partial partial X. I dot I is 1 plus partial AY over partial Y plus partial AZ over partial Z. Notice the difference. This is a vector. Component ni. Kani siya is a scalar. Right? And these are AX, AY, AZ. Kani kay U, U, U. This is called the divergence. We will not be using that one now. Ako na siyang gi-introduce. In fact, we also have another operator that we can do this with this one. Del cross A. The curl. This is divergence. This is the curl. The curl is actually some sort of how the vector can induce rotation to a something. Like if you put this, na kay flow sa tubig, no? If you put this, part of the dire, on this edge, there's a flow. On the other edge, there's a flow. Will the flow create a rotation on this one or not? In what direction? So this is given by that. That's important. When you go to fluid mechanics, We will not be using this one. Fortunately for you, we will not be using this one. There is ato ang klase. So we'll just erase this. This is called the gradient. Okay. That gradient. Now let's actually understand that gradient. Oh, by the way, let's understand first a scalar field function. What is a scalar field function? Yan lang. Gare-record pa basi naputol. Gare-record ra. Okay. Okay, nasabtan ninyo taman dire. Okay. Let's understand the gradient. I mean, the scalar field. We already know the vector field, right? An arrow at each point. At each point in space, you have an arrow and the magnitude of the arrow. That's a vector field. It's like, katong makita niyo. And I think we visualized that one in first or second meeting. Tama? Okay. Now, a scalar field. What is a scalar field? Think of a scalar field as, let's say U. Let's take U. U of x, y. 2 dimensions lang sa ata. U of x, y. So, meaning our space is this board. Let U of x, y to be the temperature at the point x, y. Tama? The temperature at every point on this board. Suppose nga na ay lain-lain klase nga temperature diri, right? Now, this is some sort of temperature. And let's say, whatever is that, a distribution of temperature. Ako ninyo? But, at this point, na-value ang U, right? It could be 5. At this point, na-value ang U, it could be 20, right? So, at any point, x, y, if this is my origin, U will have a value at this point. How about this? U will also have another value. This is R1. So, usay value sa U diha, U of R1. Tama? Kani? U of R2. Now, instead of having a number, since we could not write a number, we represent that as colors. Take the colors to be red as the hottest and the blue as the coldest, to the violet. Muna itong gamiton. So that means that since it is a temperature distribution, you will see colors on the board, right? Not only white. So imagine there are colors on the board. Okay, imagine now. May colors on the board. Okay, okay, I'll put just an example function. Because there's something surprising that will happen here whenever I want to evaluate certain colors. And this is not a coincidence. This is actually a property of, anyway, suppose I'll take the function 100 minus x squared minus y squared. This is a function, a scalar valued function. It gives us, let's say, the temperature, or now, let's say the color. The temperature varies from 0 to 100. Meaning 100 will be red, right? Very red. 0 will be very violet. Tama? Okay. So, xy is the point in this. No, you can set the origin at the center, and then this is some up to 10, and then 10 po dito, or pwede 5, whatever is that, no? So, what is now the temp? For example, kani, let's say color yellow is 70. U equals 70 means color yellow. Nakay makita ng mga yellows, right? Nakay makita ng, do you see yellow? Asa man? Okay, na-diri dapit. Do you see yellow? Okay. Imong ipon, sir. Okay. So, but do you see yellow? Yes. Now, what if we want to turn off every other color except that special yellow, that bright yellow? So, what would we see? I will turn off all the colors. So, what you will see are yellows, right? Only the points which are yellows. That means, that is equivalent to when U is, let's take this as 19 na lang, no? 19. Para mas dali siya i-evaluate. Let's say 19. Yellow is 19. Bright yellow, 19 na lang, 19. So, I will set U equals 19, right? Tama? U equals 19. And I'm going to find the points that correspond to bright yellow. I can solve that, right? By solving the equation, and this is equal to 100 minus x squared minus y squared. This is equal to x squared plus y squared equals 81. So they will form a figure, not just a random something. It's a smooth figure. And what is this? This is a circle of radius 9. Meaning, tanan to sila here are colored yellow. It's not just any random nga diri. It's regular. It's connected. It's some sort of smooth. It might be not connected. Nasabtan ninyo? So, kanisya, solving for x and y, we know that these are points. So, that means that we have what we call a curve. Right there. We form a curve. A scalar field is not a curve. It's the colors, dire. But when you set that special value of the color, you will see a curve. Now, let's go to 3D. Our function now is u of x, y, and z. Imagine this one. I think dulum na. Can you... Ha? Okay pa? Murag dulum na ba eh? Paki-on daw ang isa lang ka-layer. Try to... Atong dito nga other side daw. So, ayaw na lang sa. Kaya pa man. Okay. This is now, instead of the board, we are now seeing colors on this room. And, let's say, pareho gapon, 100 minus x squared minus y squared minus z squared. And then, I'll find all the yellow. What will I have? Well, what will I get? X squared plus y squared plus z squared equals 81. Which is, it will form a sphere. That means, setting a constant, setting this one, setting u equals constant, will give me a surface. So, two-dimensional ganihang a function, two-dimensional scalar field, you get a curve. A two-dimensional scalar function is not a curve. But setting it a constant, you get a curve. For a three-dimensional scalar field, setting it to constant, you get what? You get a surface. And that surface is regular. Well, it could be not regular. Okay, actually, yeah. Muna yung nasabtan. So, imagine that this is this surface. This is that one. Okay, see. Dili kay ganiya, lecture ko sa kwan, wala day na anong zipper. Pero okay naman kayo, nakapilit man po. Basin wala sa video, bastos yung teacher. Okay. So this is a sample of a surface, right? At every point, now this surface is of the, when we say surface is of the same color, right? So this surface is exactly of the same color. Let's say this color is red. Let's say this has a value of 95. Okay? Init kayo. Now, at any point in that surface, that is, okay, at any point, there's an R dito, right? Tama? Okay. So, mauna siya karon ang, I would like to get, you now understand the scalar field. Okay? Now, a scalar field of three dimensions is not a surface, it's a color in this space. Only you find a surface if you turn off all other colors except only one color. And you will be surprised, you will find a figure. Okay? Much like a curve. So, what I want really is actually du. The total differential. What is du? Sa one dimension, u versus x, u. du over dx is the slope of u with respect in x, right? For one dimension. Meaning that this axis right here is u, not y, because we are in one dimension. So du over dx is the slope. So what if paana ka dire? You have now y, tama, dire? On the side. You can also get the slope along y, tama? Right? So you have du over dx, partial u over partial x, and partial u over partial y, the same as this one. Think of xy as the floor. Kanisha, okay, I can go to this direction. Okay, no, sorry. Think of this, di ba na siya ana-ana, no? I'll put it in this one. Kani straight dire. That cross. So, na siya dire, kani. What is my, kanina lang siya dire. Y is going, x, y. As you can see, the function, as you go in the direction of y, the function doesn't change much. Much. Okay. Kamina, nakabulol-bulol na ko. Pero dire, as you climb, it changes heavily. So ato pa, partial u over partial x is large than partial u over partial y. Now, I want to make a vector out of those slope. And what would I get? I will get partial u over partial x, I hat, right? Plus partial u over partial y, j hat, plus over partial z, k hat. Kung saan man siya? This is del u. That is the meaning of the gradient. But, medyo basic pa kayo na, simplified pa kayo na. At least, it's just the vector formed by the slopes. Not actually the slope. How you changes, not actually slope, some sort of slope. Okay? Sabtan. Now, in calculus, when we take, if we have a function u, which is a function of x, y, and z, what is the total differential u? In calculus, I will not prove this one. I will not discuss this one because medyo taas na sa istorya ani. But du is just partial u over partial x dx plus partial u over partial y dy plus partial u, I'll write it clearly there, no? Du is partial u over partial x dx plus partial u over partial y dy plus partial u over partial z dz. This is the total the differential u, du. How that changes absolutely as you move. Okay? Now, ani, balik na ta diri karon. We are moving. We have a scalar field. We have a color right here. Color on the board. We are moving to the curve. How f changes as we move to this one? That's what we want to get. How, not f, how u changes. Imagine the board has a color. And in every color na i-attach nga vector dito. That force f. You understand? Okay. So, okay, I'll erase this one. Asa na to? What is our equation now? Oh, the left-hand side. The left-hand side would be the W is the F dot dr. And now this becomes FC dot dr plus integral of FC. But what is FC? Wait, by the way, sorry, wala pa na nakita. In general, in 3 dimensions, a force is conservative if F is the gradient of a scalar function u. Same dire. This is think of it as a derivative. Okay? With respect to our coordinates. Okay? Nakuha? So, since this is FC, then that means that we can find a function u such that this f is minus del u, right? Or, ano natin buhaton? Let's take the negative here. Minus del u dot dr. But what is del u dot dr? And, asa naman ta, sir? Simple naman ito ganyan pagsugod na ito, di ba? It's very simple. But, it will be rewarding when we go back. Okay. Del u dot dr. Okay. What is del u dot dr? This is integral of f nc dot dr minus the integral of, by the way, this is evaluated from, okay, anyway, del u dot dr. What is del u? This is partial u over partial x, I plus partial u over partial y, j plus partial u over partial z, k, dot, what is dr? dxi plus dyj plus dzk. I introduce this meeting. That's why grabe ang introduction sa inyo ha. And this now becomes F, or we can just call this W, no? NC. Kani siya. Minus this one. Kani ipares nato dito. We have an integral of partial u over partial x dx plus partial u over partial y dy plus partial u over partial z dz. But what is this one? That is du. Okay. So this is NC minus the integral of du. This is evaluated. Well, of course, karon, since this is now u of x naught, y naught, and z naught, right? The initial to u of x, y, and z. What is the integral of du? U. So this is now equal to minus, WNC minus u. But this is u of x, y, z minus u of x naught, y naught, and z naught. Or we can call this as WNC minus delta u. Okay. Delta u. Let's understand this one. Notice this one. Suppose dirita nagsugod, and then we go with this one. What is delta u? U does not depend on any intermediary points. It only depends on the initial and the final. That means if we pass through here, it will be the same, right? Tama? Because the path the parameterization R did not appear. Did it appear? No. We are integrating over du dire. That means even if we take this route, it does not matter. Okay? Wow. Wow. Okay. Nakuha. Now, what is that u? That is the function associated with the force field. That scalar field. And we now, okay, unsa ni siya karon? This equation now, what is now our equation? Our equation, I'll erase kanina. Our equation, the left-hand side becomes WNC minus delta U equals delta K. Now, that W, we call this the work done. Because that is something that is being added, an energy. Because this is a unit of energy. This must also be a unit of energy. So what that work is doing, W, F.dr, it either adds something to the system. And what is that being added? Energy. Or removes something to the system. What is being removed? Energy. Mauna ang F.dr. Whenever we are moving such that the force is assisting us, we get a energy, a positive energy. Whenever we are against a force, the energy is decreasing. And what is U? U is called the potential energy. So K is the kinetic energy, and U is the potential energy. Okay, I think we have to extend about mga 15 minutes. Okay. Okay. Now, for example, what is in gravity? What is the associated potential? Because, as I've said, gravity is a conservative force, right? So, it's position dependent, but Does it depend ang weight diri ug diri? Does it change? No, it's mg, right? And mg. Pero anong position dependent man na siya? Well, it's position dependent. What we want is actually the general is not position. The general weight is actually position dependent. Pero katong weight nga itong ginaano dire, as long as we are surface of the earth is the same, but then this whether the same na siya, since it is a conservative force, it must arise from a potential. What is Fg, gravitational force? That is minus mg, right? Okay. Let's just take that as mg. What is that function that when you differentiate to a coordinates, you get mg? What is u? U must be mg times the coordinates, right? And that would be y. U must be equal to, this is minus mg di. So that F equals minus, tanawa, du over dy. What do you get? Minus mg. So what is mgy? This is the potential energy. And y is as measured the height from a certain zero. This zero is arbitrary. It depends on asa nato iset. Nasabtan niyo? Okay. Or mgh. You can call this as mgh na lang, no? Height. So this is what we call the gravitational potential energy. Again, this is not the correct gravitational potential energy. This is an approximate gravitational potential energy. But it's true at the surface of the Earth. Okay? So, here, tanaw na to. What happens if we don't have friction? Meaning no non-conservative force. This will be 0 because F and C is 0. So if no F and C, what do we get? Our equation becomes delta K plus delta U equals 0. But then, this is the sum of the total energy. Let's define the total energy of the system to be the sum of kinetic energy plus the potential energy of the system. So this one here is what we call the change in total energy. Delta E is equal to 0. This is the conservation of energy. Mechanical energy. Kani siya. Unsa man ni siya? Okay? What is this equation? Meaning ani, if delta E equals 0, if delta E is 0, that means that, unsa man ni siya? This is E2 minus E1 equals 0, right? Or we have E1 is just equal to E2. That means as you, okay? Nakuha? As you move from this point 1, and this is point 2, if the energy here is E, and the energy here is also, the energy here but it also E. Okay? So, in fact, if we have n particles, kada particles, we also have the total energy. Okay? Energy is additive per particle actually. No? So you have, let's say, na kay E1, E2, E3. Okay? So you can have na kay particle diri nga move dito, but actually that's also the system of particles. But anyway, you can have this, the total energy of the system is just equal to E1 plus E2 plus, and so on. Okay? This is equal to E tot. Ito, E lang. Okay. So, isa ilunggo diri. Okay. So anyway, we have E1 is equal to E2. E initial is equal to E final. Now, what is E initial? What is the kinetic energy initial? That is 1/2 m V1 squared. Plus, what is the initial potential energy? mgh1, right? Equals 1/2 mv2 squared plus mgh2. And you already know this equation. This is the equation nga gihatag sa inyo sa una when you're in senior high. and look like that we have come taas kayo. Pero ganahan mo magtaas, no? Tagahan na mag-formula. Tagahan na mag-formula. Dayon, solve dayon. That's not happening to me. Tanawag yun sa nato pagkuhan, di ba? Okay? So you see the pero it's rewarding, right? Because we medyo ni adto ta na natay adventure nga gibuhat. It's not about finding answers. It's about the adventure you kumbaga pa the adventure that you experience in searching for the answer. It's about the question. Okay, nasabtan ninyo? Okay, now how can we use this dito? Okay. Balik ta dire. A, right? What is the velocity at this point? Well, let's take this as point 1 and point 2. 1/2 mv1 squared plus mg h, so h1 equals 1/2 mv2 squared plus mg h2. This was our kuan ganiya, di ba? And then what is h2? That is just 0. What is v1? That is 0. What is h1? That is just h. So v2 we are looking for that. So you have cancel lang m, 2gh equals v2 squared, and you get v equals square root of 2gh. But this is one line. How about the three anak? A, B, and C. This is B not equal 0. And then we want to find the velocity at C. We don't need this. All we need to do is evaluate point 1 and point 2. Oh, that is 1/2 m v1 squared plus mg h1. What is h1? That is just h1 plus h2 plus h3. Or that is h. Equals 1/2 m v c squared plus mgh kaning dire 2, which is again 0, but this is just equal to h. So 0, 0, you got 2gh equals vc squared, and it is just one line. And you see now what we develop is, that's why is it worth it that we nagkalisod ta? And that's how we actually improve as a person, as a people. You take the difficulty, and from that difficulty, you have this tool right here. A tool that actually gives you is technology. And a lot of learning. Because unsay na ano ninyo karon, you not only that you learn that there is an easy way. You learn about what? Partial derivative, about scalar field, about that is the adventure, that is the importance. Nga ato ni siyang giano. I can give you this directly. No? Basta bugo akong estudyante, ihatag lang ako na diretso. Hindi mo bugo, di ba? Hala, sa section nga akong gihatagaan lang diretso ani. Pero kwanto siya dito kay tungod kay nauhot na mig oras gidiretso na naghatag sa ilahin, and then I told them nga I'll make a video on this one. Masima ano nila ba? Sir, gitagaan ra ba ni Mimiana, sir? Okay. So, anyway, di ba unsay na ano nato? Di ba is it rewarding in the end? Remember nga, what if ani ato ang ano ganiha? Mag-ani-ani atong path. Taas kayo. And what if curve na siya? Now, will the curve matter? Well, it doesn't matter. Well, here we are assuming that no non-conservative force. If there is non-conservative force, then the equation is not this. The equation is WNC equals delta E. The change in the energy, meaning that the non-conservative force will cause the total energy to decrease. And that's why, tanawa, okay, cameraman. Okay, what is the potential energy here? No. Let's take that to be, let's say, yeah, pwede siya ma-0, no? We can set this to 0. What's the potential energy at this point? We can, maybe 5. So at this point, pala potential energy. Does it change height? No, it's 5, right? Okay. Now, I'll give this a initial velocity. Let's say the initial velocity is okay. Okay. Velocity is, let's say, 3. 3 ang initial velocity, but then pag abot diri, pila? 0. So pilay total energy diri. That's pila tong initial velocity, potential energy dire? What's it? 5. Plus, what's the kinetic energy here? No. It's 3 squared plus, let's say, 1. So that's 9. So pila? 14, no? 9 plus 5, 14. Now, what is the energy here? What's the kinetic energy? 0. And then what's the potential? 0. 5. No. Di ba nag-decrease? What is causing the decrease? The non-conservative force. That non-conservative force is friction. Without friction, it will have no reason to stop. Sabta ninyo? Okay, sir, siya. Okay. It will not stop. Nga naman, because its energy is maintained. So, constant ang potential, 5. So, asa na padulong ang 9? Wala. Naragyapon dito, right? So, that's why it has to move because it has still energy. But then, if friction is eating that energy, friction is actually the one that is eating the energy. Okay? Nasabtan ninyo? Okay. That's why, if there's a non-conservative, that system will tend to, okay. Now, is there a work done by the conservative force? Yes, the conservative force does work. What is the work done by the conservative force? That's just the change in the negative of the change of the potential energy. The weight does work. But the weight, delta U, that's why gina-add niya. Kasi pag add mo ni ihulog dito, it adds energy to the system. Asa na siya gagpadulong? Sa kinetic energy. That's the work done by the gravity. Asa mapadulong to? Sa kinetic energy. Is there a work done by the gravity, by the conservative force? Yes. But that work done is independent of the path. And that's why katong ganiha, paana dito, as long as the same ang dire, it doesn't matter. Pakion na lang daw, kay ngit-ngit na daw. Okay? Okay. Maklaro na akong kuan. Oily. Naka-beautify na siya. Ako pa rin yun ang i-beautify o niya. Dungag, double rendering. Kita, salig na lang ta sa ko So, pero okay ra gyapon na. Kita mga batig na, kita mo po yung mga maayong diskarte. Kaya nga naman, di ka mo diskarte, di mga kakauyab. Magulat ra ka diha na. It's actually the difficulty that pushes us to, the difficulty of solving ganiha pushes us to find means in order to simplify things. So anyway, so katong diri, sa nagani ko? Yeah, it's path independent, right? Di ba? Bisag unsa ganiha, right? As you notice, bisag unsa pa itsura ato. As long as the same height. Sir, why not the same? Lahi-lahi man sila og diri, sir. Yes, bisag lahi-lahi sila. Why? Because the potential energy does not depend on X. It only depends on Y. As long as the same, Okay? So that's that's how we analyze energy. And the rest is just problem solving. Okay? So sa problem solving na ta magkita balik. Because the problem now becomes difficult if we put non-conservative forces. Okay? Now, ano ni siya? Also, before we end, there's this perpetual machine nga advertisement. I don't know, nakita na nimo. Pag nasa plato dira, the plate looks like this. Pag yana nimo, no? On this view. And then there's something that you mahulog dire and then moana siya dito. Then ay ani gamay. And then pag ana niya da murag jolen siya, no? Marble. Okay? There's a plate. And then it will fall ani pak. Pag ana mo balik siya dire. And they're advertising that one as a perpetual machine. why is it nga dili na siya tinuod? Well, of course, the manufacturer doesn't, they know exactly that it's not true. Why? Because assuming that the initial velocity is kani, notice that if the initial velocity is v naught is 0, assuming there's no friction, what is the velocity pag abot dire? It must also be 0. In fact, dire, if the velocity is 5, what is the velocity here? The speed? 5. So, kung asa siya mo abot, diha lang. Will it have the velocity nga mo ana siya dire? No. No. Bisan pag anihon na siya nimo, pag abot niya, yes, makaabot na siya dire, pero pag abot, when it reaches here, it becomes 0. And since there's friction, di siya kaabot dira, asa lang siya? Dire ra siya. But what will it take in order for it to reach this one? You have to add an V naught should not be equal to 0. That's why, when it reaches this point right here, nga mo disconnect na siya sa it has to have a V naught dire. Tama? And if you have a V naught dire, it can reach by projectile. So, two types of motion. So, there has to be a battery or a magnet, I don't know, sige, nabuhat nila dira. But not only the work done by gravity. Why? Because if 0 lang siya, gidrop lang siya dira, it will become 0 dire. That's assuming wala friction. But there's friction on that. There's friction everywhere, right? Okay, life is boring without friction. There's always friction. It's impossible to have a system without friction. You can, na yung mga problem of frictionless, meaning that when the dimension becomes small enough that we don't consider the dimension to be large enough, so we can take it as frictionless or very smooth. Okay? Pero pag sufficiently large na siya, we have to include friction. Okay? Anyway, so, next meeting, unsa ba? Mag-quiz na mo. Kamu na yung mag-solve. Oh, di ba natin katong kanta, katong sayawan ay? Oh. Mag-ano lang ta, mag-recital. Ay, magsayawan ta. Karang question and answer, hindi katubag mo sayaw. Pero pag di ka mo sayaw, minus. Appeal ni siya dire. Oh, katong music. Dili, individual. Damayon man mo ng uban. Sige na, James.